Okay, welcome to Smarter R. So today I will show you how to create a climate stripe, which is very popular right now when we try to visualize our climate data, especially temperature, rainfall, something like that. But this time I will show you how to create a climate stripe that is moving. So that is more interactive, more very good for your presentation. So let me share the screen, entire screen share. So, okay. Now, what I want to show you is actually something like this. Can you see this one? Yeah, you can see this, right? So, this is climate stripe, but it is moving from the earlier year until future projection. This is what I do for climate future projection. So my presentation, I'm using this climate stripe instead of the static one. So I'm preparing the dynamic one, the moving one. I call it. This is in the form of a race chart. If you ever heard of race chart is very popular. People do some metrics, something like that in YouTube. People see over the year what is changing between the countries. So, but this time we use that race chart and then incorporate it into climate stripe. So it will look more moving, something like that. So let's start with our tutorial. So for this climate stripe, what you need is you need certain libraries. So you need to install ggplot2, gganimate to animate the plot, and then dplayer. So install this library first, and then I have run this one. Let's see, make sure that everybody know that the code is running correctly. So and then we set our working directory where we put our data set. So I have my future projection for SSP5, if you know that climate scenario. So I put it in the research, this folder. Set working directory is our folder. So I put in D, research, GCRF, federal event here, and then I put in the analysis. So my data set is, we read our data set that as read.csv. So I put my data set as CSV file. Header is equal to 2. So my data set is this one. Peninsula Malaysia, maximum temperature, race chart, SSP5. So P, this one. Okay, this one down here. So let's see our data set. Let's remove this one. So our data set is very simple. So you have year. This is yearly. I put race chart for yearly based on era 5 data set, and then I'm downscale the data, the future projection by using downscaling, and then it's project the future projection until 2100 from 1950 to 2100. And this is the SSP5 for temperature, maximum temperature, mean maximum temperature for 1950 until 2100, projection until 2100. So you only have year and SSP5 worst case scenario for maximum temperature. So this is how I arrange my input data. So you can read this one, we can read this one. So you can view this data also just by using view function. By using view function, you can see what is our data there. Our input data just now, you see here and SSP5 from 1950 to 2100. Now we create a climate stripe plot with the year center and enlarge. So climate stripe, we create our climate stripe by using ggplot. So we use our date just now, date, and then we put AES. That's mean x, y axis of that plot. X axis will be year, down there will be year. Y axis is equal to 1. And then fill equal to SSP5. We want to fill the plot with the data from SSP5. So group equal to year. And then geometry ES width equal to 1, height equal to 0.5. So we want to make a plot with the width 1 and the height 0.5. And then we scale the fill gradient. So the lower value will be blue, the high value will be red. So that's mean in the range between the lower temperature and high temperature is moving from blue to red. It's up to you if you want to change other color from yellow or red or something like that, but I like blue to red. So most people climate stripe, they use blue to red. And we name it as temperature. temperature, this with the Celsius. Team void team legend position equal to bottom. So we put the legend at the bottom. And then element text, size of the text, adjust, face is equal to bold, something like that. This is just the text fonts adjustment, if you want to call it. And then we labs title equal to year, and then closest state. We do a transition state year, transition length equal to 1, state length equal to 1, web false, linear, shadow marks. So this is all the code that you need for creating a climate stripe. So now you run this one. Now it's run. It's run, but first it's not there. You must first animate it. So you must animate it by using, let me do this. Okay. So to animate it, you use animate function. Use this animate function. So you use your climate stripe just now with n frames equal to 200, FPS equal to 10, width equal to 800, height 200. Renderer you use the GIF ski renderer for climate stripe, res chart retain. So this is your GIF file, will be your GIF file. So you run it. After you run it, now it will render the file. It will render the file first. It will take a few seconds. 4, 3, 2, 1. Now. Now it's this is your climate stripe. Now you have prepared your own climate stripe in the form of res chart. So you see from earlier the maximum temperature is quite low. Now it's frequently increasing more up to 34 degrees. From in the past it's quite low, less than 29 degrees Celsius, and some year after that is after 1990 still 29. After that all of the temperature moving up to 31, 32, 33 and 34 degrees Celsius, especially at the end of the century, 2100. So this is how you prepare your climate stripe. And this you can save the animation by using animsave function in R. So this will save your GIF file. You can name it whatever you want. So animation equal to last animation. So I think that's all for today. I hope this tutorial will be very helpful for you. Thank you for watching.